We are talking about closed loop recycling, but before we talk about closed loop recycling of water, we need to understand where the concept of this closed loop actually originates. In the last 100 years, human development, our growth has been very linear, but nature doesn't work like that. It's cyclic. There's a start, there's growth, there's maturity, there's dying, and then there's reboot. And that is the default design of nature. Byproducts are always the starting point for new life. And that is the essence of creating a circular economy or creating a closed loop recycling, system. So that's what we want to do. We want to create that awareness so that everybody is able to recycle their wastewater, because that is the only way we can have a water secure future.
Yes, the first step in climate action and sustainability practices is creating awareness. This episode is about how a startup has worked around creating awareness and implementing projects in wastewater management. Stay tuned for an insightful conversation. Hello and a big warm welcome to yet another episode on the Mission Shunya podcast. Hope you're doing well. If you are part of the select few who write to me regularly, providing feedback about the episodes, stories, etc., a special welcome to you. I read each and every single message and acknowledge them. Feedback is always welcome. missionshunya@gmail.com is the ID. You can also tag Mission Shunya across the social media platforms. One such feedback that I received a year ago was asking about wastewater management. The intent being, water is a stressed asset and we waste a lot of water during our use. So yes, I was looking around to see stories of entrepreneurs and evangelists who were pioneering wastewater management, especially having experience in delivering both new and retrofit system. And I found someone who offers it using organic methods and is decently scalable. So let's get to the story with our guest, who is...
Hi, my name is Aditi, and my organization, Organic Solutions, is basically committed to creating water abundance. We are trying to provide nature-based solutions for recycling of wastewater on-site for communities and institutions, and helping them reduce their burden of fresh water and enabling water sustainability for all.
Thanks, Aditi. Now, let's begin with your story. You're dealing with one of the biggest problems that cities in general and everyone faces in dealing with wastewater, and how do you treat them and how do you close the loop there. But how did you end up trying to solve this problem? What's your journey been so far until you got here?
So, Girish, I think we're all connected to water consciously or subconsciously. After all, 75% of our body and the planet is water.
Fair.
And, my connection with water came at a young age. We moved from Delhi to Gurgaon, and, I got introduced to the concept of water tankers and having a few no water days. And if I look back, the situation was nowhere as bad as it is today. But even those very small random incidents made me question water availability and the path of water in and out of our houses. And, then I moved to Singapore to study, and the water reality there, the reality that I saw there was so different. It was so futuristic. Anyways, I came back and I started working for a consulting firm. But very soon, I found myself in a position where I didn't like what was happening to the planet around us, and I wanted to contribute positively to it. And, I think that's when the penny first dropped, somewhere back in 2009-10, when I realized that if we don't fix the environmental situation that we're heading into, there will be no future generations. And, the term social entrepreneurship was fairly new at that time. And I was very excited about this prospect of doing good and being able to make a living out of that. So I quit, and that's that. And why I chose wastewater? Well, because, the potential is immense. Our sewage is literally everywhere.
Correct.
So that's how, Organic Solutions, what we do at Organic Solutions is that we are basically committed to creating water abundance. And, we want to move the dialogue from water scarcity to water abundance. We're all talking about water scarcity today, but, there is a way to move towards water abundance, and that's what we want to do. And our vision is to, transform how wastewater is viewed in our society, because we're only looking at flush and forget culture right now. So we want to move away from that. We want to make communities move away from that single use culture and stop depleting the finite water resources that we have, because apart from the environmental consequences, wastewater actually has value, which we want to keep within the economy. So that's what we do. We provide nature-based solutions for closed-loop recycling of water on site for communities, for institutions. So in a sense, we are reducing the burden on freshwater resources and enabling water sustainability.
That's wonderful. I like the word like water abundance. And you do mention that your experience in Singapore. I mean, that's like, even if you live in large metropolis, like in most places around the world, people just say like you can just drink water out of the tap. But we haven't got there yet, especially in India, but it's slowly getting there.
Yes, it is.
So eventually, when we get there, I think all the solutions that you're developing is going to be very critical, because everything has to be treated at source, and you have to close the loop at source. So that is a very big problem. And you did mention that it's been an entrepreneurial journey, and although you say it's a social entrepreneurship, but I think it is much more than that, right? Because there is huge potential, there is huge market value, and along with it comes an economic value as well. So the last decade or so, you must have definitely seen a good growth and good response to your business and value proposition, correct?
Yes, definitely. In the last decade, with the norms getting stricter, and the government also kind of giving a push wherein sewage treatment is becoming mandatory for newer establishments and for newer communities that are coming up. We definitely see that the wave is changing. People are becoming more aware of the terminology itself. I mean, 10 years back, people weren't even aware of sewage treatment, or what really is sewage treatment all about, and what are the different ways that you can treat your wastewater. But I think people are becoming more aware now, and I would say people are also now becoming more open to the idea of recycling waste. Having said that, like you mentioned, in Singapore, in California, there's so many places in the world where wastewater is now being treated to the quality of drinking water. But in India, there is a huge social stigma when it comes to treating our wastewater and then drinking it. We keep things different for our kitchen and things different for our bathroom, and so there is a huge stigma. And we're not getting into changing that for people right away, because it's a slow moving process. It's a step towards the end goal. So the first step is to actually make them ready to even recycle their wastewater for non-potable uses, and that's what our focus right now is. Because there's so many uses for which we're using potable water, and we don't really need to do that. So if we can recycle our wastewater for that, I think it's a big win.
That's wonderful. It starts small, but start with some intent and some scale. Now, looking at this, you did mention for non-portable use. So I assume that could be something like gardening and using it for other cleaning purposes. But in terms of typical household, what is a residential complex, a medium-sized residential complex in an urban city? What is the scale that is possible to have these kind of solutions implemented?
So the scale is immense, because actually only 30 to 40% of our water is the true potable demand, what we need for our showers maybe, and cooking and drinking. But currently people are spending money to buy potable water for all their uses. And literally in one toilet flush, you have sent it down the drain. You've contaminated that water instantly. And then, our municipality spends our tax money to retreat that water, because a lot of it is entering our freshwater resources. Our lakes, our ponds, our rivers are all getting severely polluted. And then they send it back to us as potable water, and then we buy it again. Or we are buying tankers of water, which is mostly groundwater extraction, which is done illegally. And we keep on repeating the cycle. It's insanity. I mean, why do we need drinking water quality to water our plants, to wash our car, or to flush our toilets? 200 years ago, water was abundant. Our population was not as much, our pollution was not as much. And we were flushing it down, and the impact was not visible. But our wastewater is not invisible anymore, and we need to start tapping it, reusing it if we want a water secure future. So, we are committed to make wastewater recycling accessible for everyone. So we have a system that can be installed for, say, a single household where they can treat their grey water or sewage and recycle it to wash their cars, to water their plants, to reflush if they have dual plumbing, sorry. And we provide solutions to small and big communities like a residential township or even a village, to institutions like schools, colleges, offices. We have set up systems for public parks in Gurgaon, where sewage is extracted from the sewer line near the park, treated in the park, and the treated water irrigates the park. Villages can set up the system to recycle the wastewater to fill their ponds or to irrigate their farms. So sewage recycling solutions can actually be deployed at any scale, basically wherever sewage is available. And our sewage is all pervasive; it's everywhere. So the scale is immense. And we call it sewer mining, because you need water somewhere, you tap the sewer, you treat the sewage, and voila, you have water that you can reuse. So that's the scale that we're looking at.
So this entire thing about closed loop recycling using water as a product and solution, you have multiple ones for small scale and one for also like a large complex, and in different products, different solutions. Is this solution, like for example, is it easy to retrofit, and what is the process there involved? Because I assume when you have to build something new, like a new residential complex, having the systems in place is a little easy, but how easy is it for you to get in a residential complex and try to retrofit the system, a small one or a big one? So how easy or difficult is it?
So it's not difficult to retrofit it in an existing community or a township or an existing school or an institution. It's definitely more easier to plan when it's a newer township or a newer establishment. But having said that, we have set up STPs in existing townships, so it can be constructed as a civil structure. Or we can have prefabricated structures, or we can have small plug-and-play modules and can then, be scaled up according to whatever the flow is. And we're even looking at, deploying container-based systems, where they can be transported from one place to another. So the idea of treatment remains the same, wherein, we have a solution where the wastewater is getting treated. The containment can be, designed differently, or the containment can be civil or prefabricated. So retrofitting even an existing sewage treatment plant is not difficult. Say a sewage treatment plant which is dysfunctional, it's not, performing up to the mark, or say it's been abandoned. We can use the components of that sewage treatment plant and, retrofit it to actually work in our process.
The other thing about water, just like any other resource, especially in urban centers, I understand that a lot of things goes unaccounted. Like, for example, there's a lot of leakage that happens in the system, and that is probably one of the biggest wastage that happens in the entire system. I'm sure this is, although a minor component in this, do you have any systems in place to kind of check, like, okay, is this close to 100%, or are there still scope for improvement in terms of efficiency of recovery, or do you have any tools to monitor that?
So when it comes to our system, we work on something called the CPHEO manual. So, for example, we're working for an apartment complex, or say we're working for a township, then we know the number of flats will have X number of people and would then generate X number of, X liters of wastewater. So these are standards, by which the designing is done. And you can have flow meters installed to basically check the amount of water that is actually entering into the system. And in terms of recovery, we have, almost above 95% recovery. The only losses would be some evaporation that might happen from the reactor bed. So we can also have flow meters installed to check in the amount of water that is coming in, and then going out of the system. So that way, that correlation of recovery can be done from the system. In terms of leakages that are happening at the upstream, then it becomes a completely different project wherein, we're looking at also reducing the water consumption. We're trying to tap the fact that no water is getting wasted, and then whatever wasted water that is coming out of our toilets or our kitchens or say other areas is then getting treated and then going back into the circle again. Currently, our focus is to basically give that water back for recycling. But definitely with, smart solutions like IoT You can have flow meters that are installed at various levels in the infrastructure, and then water flow can be measured from there. And then you can always make out whether, say, if you had, let's say, a freshwater tank and it was filled with, say, 1,000 liters of water, but the taps and everything are not getting that much water, or say our plant is not getting that much water, then we know that there is some leakage somewhere. So we can always identify that.
That's really good. That's really good to know when you have all the flow meters and sensors in place. It's more easily to track, because when having spoken to a few stakeholders and asking about the sustainable initiatives they have taken, I kind of come across this point when they tell that we know there is a lot of leakage that's happening in a system, especially a large community. When a large system water flows in, but there are leakages everywhere, even within that apartment complex, big residential complex. So I think that will be their first problem that they want to solve when you present such solutions. Now the other part is like also about the testing of the quality of the water once it's recycled. So are there any specific tests that you undertake, or is it common test, or how do you convince people saying like, okay, this water is really good and the quality is definitely on par with potable water?
Like I said, the idea is not to make it potable water, even though the technology exists to do that. But when it comes to recycling of water for non-potable uses, the last decade has been quite the water action decade, even in our country, wherein, stringent norms have come into place where, people have to meet those particular standards if they want to use the water for flushing or for, say, gardening or for, say, construction, whatever that they want to use this water for. So there are standards that have been set out by the Central Pollution Control Board of India. And then there are stringent standards that have been set out by the NGT, the National Green Tribunal.
Fair.
So our systems are designed to basically meet those standards. So whatever water that is coming out of our treatment systems is meeting those norms. And there are laboratory tests that can be done on the samples that, are picked up from the outlet of the treatment system. And they can be tested. So we encourage our clients to get the testing done themselves, because that is what builds the trust. Because if I pick up the sample, they can always tell me, I don't know what you've done to the sample. So we encourage them to pick them up themselves and then get it tested in any accredited lab. And then they can match it with the standards that have been set out by the government of India. And that's when you know that the water is fit for use. But if you just look at certain olfactory measures, like if you smell the water, if you look at the water, it will look like drinking water. But definitely, it's important to get these tests done to, get to build that trust with our clients. So we keep getting them done regularly for our systems, and whether the client wants to get it done themselves, and we encourage them to do it themselves as well.
Correct. Quality and trust is one thing that the clients look for. But the other part that definitely clients look for is the cost factor, especially when new systems come saying like they are sustainable and they are good for the planet. There is this general perception that it is going to be costly. It's going to be a little expensive compared to the alternate ones. So why should we invest in these systems? So how do you go about convincing clients to adopt better solutions? Are you cost competitive, or if I were to put it, better than the current market prices for existing systems?
The problem that the industry faces currently is that there are so many STP providers that are providing different technologies, and there is absolutely no apples to oranges comparisons that happen. Right. So when we were developing a solution for wastewater treatment, we wanted to create a sustainable solution that will actually be an asset to the user instead of a liability.
Correct.
When I say that, what I really mean is that if you look at what is happening in our country right now is that India is generating about 7,200 crore liters of sewage every single day. Out of this, only 2,000 crore liters is treated. And, the rest is being discharged directly into groundwater or, say, freshwater resources. And that is what has led most of our ponds, lakes, rivers being severely polluted. And even the sewage that is getting treated in, big centralized STPs of our cities and our towns, it's not getting recycled back into use. And this cycle is vicious. And this is what is creating the water crisis in our country. Because these centralized options have a lot of challenges. For example, if you're transporting the sewage from all parts of a developing city to one centralized plant, it's an expensive affair. And it is also adding tremendously to the carbon footprint of wastewater treatment because of all the pumping involved. So essentially, to solve one problem, we end up creating an array of other problems. And being capital intensive projects, the demand supply gap is so huge, and which is why most of the sewage is untreated. So the simple solution that people have come up with is to basically decentralize the infrastructure. You
Fair.
basically treat the sewage at the point where it is generated, and with policy changes and the push that the government is giving, there's definitely a change, like I mentioned, towards adopting these decentralized systems. But still our sewage is reaching our lakes and rivers. And why is that happening? Because centralized systems have blindly been miniaturized for decentralized infrastructure. Now, these treatment systems require constant power. They need skill and dedicated manpower. Then they have environmental issues like, you have to dispose of sludge, or you have high carbon footprint. And unfortunately, what happens is, due to lack of knowledge, most times communities and institutions, they end up only assessing the capital costs.
Fair.
They do not factor in the life cycle costs or the costs to keep these systems running for, say, 10, 15 years. What happens when the STP provider has done his job, he's installed, and he leaves? The operation and maintenance for the community becomes cumbersome because you need to run these STPs 24/7, so you need power. In case there is a power cut, you need to give them genset backup.
Correct.
So you need 3 people to run the STP round the clock, even for the smallest one. And if you don't operate them properly, you don't get good quality of water. The treatment is not proper, then you say STPs don't work, and eventually these systems become a liability for the owners and they abandon it. And that is the biggest problem when it comes to actually treating wastewater. And we wanted to change that narrative, by creating water recycling options that were accessible to everyone, every community, every institution at the micro level. So they should be able to easily be set up and operated hassle-free for generations to come. And that is what brings me to the life cycle cost assessment of our technology vis-a-vis other system. If you do that, then the life cycle cost is much lower than these aerobic STPs. But what happens is, when we go to the clients, the only comparison that is done is cost versus cost of capital. And that is not an apples to oranges comparison, because the same technology in the market can be available for, say, 2 lakhs and then will go up to 10 lakhs also. For the same flow, the same technology, it completely depends on the way the vendor is designing it. So it becomes very difficult to do that comparison, which is why we always tell the client to look at a wholesome picture. If you're looking at setting up an asset, you need to see that this is not just to meet the government regulation. You need to actually run this STP because you want to recycle the wastewater. And if you want to do that, then you need to see whether you'll be able to run this STP for, say, 10, 15, 20 years. And that's where the economics kick in.
In terms of duration, like for the life cycle analysis, like what is the period that you take?
So usually we do an analysis of about 10 years for our clients.
Okay.
Because usually the life cycle of our STPs can go up to 20, 25 years if it's a civil structure. Okay. But if it's a prefabricated structure, then 10, 15 years. So we usually do this 10-year life cycle assessment for our clients. So if I take an example, a community of 70 flats, if they set up this STP, they're going to be basically recycling 50,000 liters of water on a daily basis. Now that's 18 crore liters of water over 10 years, or say 36,000 water tankers in 10 years. Now, if you look at the amount of money that this community, I'm not even comparing STP to STP, I'm just comparing the fact that there is a payback to setting up an STP. The community will actually spend anything between 2.5 to, say, 4.5 crores at the current price of buying the tankers. So in that sense, if you're setting up our treatment system, the payback will be, say, less than 2 years. But the only catch here is that this value of payback is realized only by people who are buying water. A lot of communities are doing that, but still a lot of communities, a lot of institutions have enough water supply. So they are not able to see this payback because the government is providing them water at a very subsidized rate currently. But what we tell them is that it's called being future ready. When the water supply will become low for you, then recycled water is the cheapest and the safest option for getting water.
That is true. As long as the true value of water, the cost is not reflected at the consumer end, then there's definitely going to be this disparity between their thoughts and what is the real value of the resources that they are using. Now, there is this perception, anything organic or anything around organic and sustainability, there's always this perception, be it like organic food, organic clothing, or even, for example, like when you say organic nature based solutions, is it really organic? Is it really true to its real sense or meaning? So how do you convince clients about what you offer is the unique thing that you're doing it?
So, when we were developing our solution, what we realized was that we need to learn, from the most sustainable teacher, and that's nature.
Fair.
Because nature has spent 3.8 billion years doing R&D that is required to sustain life on our planet.
Hmm.
It's just that we humans have moved away from those learnings and we've created all these problems for ourselves. Now, what we have done is we apply modern principles to nature's working, and that's called biomimicry
Correct.
or regenerative design, where you're giving more than what you take. And that's where we based our solution. We wanted to purify water, so we just asked the question, how does nature purify water? And we found the answer on the very ground that we stand on. It's actually the largest water filter. Whatever water that is falling onto the ground is getting filtered through various layers and then finally reaching our groundwater, which we're anyways using. So that's the basic principle. Our sewage treatment system, we call it the advanced eco-reactor. It's basically mimicking the principles of healthy soil to filter and to biologically treat wastewater, which other STP technologies are using electricity and power hogging motors to do, or blowers to blow air into the water and then creating a whole lot of other problems. If we take one spoonful of healthy soil, it has more life than the entire human population on Earth. But due to our own activities, it is very difficult to get healthy soil also. So what we have done is we've created the right mix. Basically, we've done our research on what healthy soil really looks like and what it was maybe, say, 200, 300, 400 years ago. What it had was the right mix of organic matter, some inert rock material, and a whole lot of microbial population and earthworms. So in fact, what we've done is we've turbocharged the natural process. This treatment technology is called vermifiltration.
Okay.
Basically, using the power of earthworms and microbes to treat wastewater. Because wastewater has fecal matter and other components that is food for this, for the earthworms and microbes. So wastewater is basically trickling down the various layers that are created in the STP. It doesn't look like an STP actually. It can be developed like even a garden.
Nice.
And in the process, the water gets cleaned as this whole surface that we have created gets covered with microbial biofilms. And those are the actual guys who are treating the wastewater. They are the ones who do all the work in any kind of STP. And it's a natural ecosystem, so you don't need constant external tweaking. What comes out can be safely recycled, and working in tandem with nature has so many advantages. Like we don't have to worry about separating and disposing of sludge. Sludge is basically this slurry type material of solids and dead bacteria which comes out of other STPs. People have to dispose it off, so there are costs to that. And usually they end up either in the water bodies or they end up in the landfills, creating another problem. So we don't have that. The earthworms digest all of that. They convert it into vermicompost actually. And so it's true to its nature. There is no waste. Our system does not need constant power. It can even run on solar power.
Nice.
It does not need technical staff to run it. Even a gardener can be trained to take care of it. We don't add any chemicals. And we're not contributing to climate change because our carbon footprint of the STP is low. We work with, municipalities, villages, paramilitary forces, schools, hospitals, resorts. The proof of our solution lies in the fact that, most of our installations are word of mouth references, with our clients becoming our strongest advocates. Like today I got pictures from one of our projects, we had set up for an urban village near Gurgaon. And they actually did the flag hoisting ceremony in the village next to the treatment plant. So that's testimony to the fact that we have actually created an asset for the village instead of a liability that they abandon. It's like a park, a meeting point for them. So, if we could create these systems that users don't abandon, we treat the water up to the required quality, we're not creating other problems like sludge or, carbon emissions, then we've got ourselves a sustainable way forward and it shows.
That's true. Clients are definitely the biggest supporters. And when you have people giving you references from previous clients, then that's really a sign that the solution definitely works. And there is a lot of evangelism that happens in that way. So Aditi, on a final note, like the solution is good. And so what are your next plans in the next few years to scale this up as a business? Where do you see it going forward? And how can people get in touch with you? And how can they help you in this business?
So Girish, we're, like I mentioned, the scale that we're working at is that sewage is everywhere. And, the first point has been so far for us also to create awareness and to create knowledge around, nature-based solutions. And I don't see that ending anytime soon, because just in India, it's such a vast market. And I would say that, we've only maybe touched 1% of the people. The first step is to create awareness. We are talking about closed loop recycling, but before we talk about closed loop recycling of water, we need to understand where the concept of this closed loop actually originates. In the last 100 years, human development, our growth has been very linear.
Correct.
But nature doesn't work like that. It's cyclic. There's a start, there's growth, there's maturity, there's dying, and then there's reboot. And that is the default design of nature.
Exactly.
Byproducts are always the starting point for new life. And that is the essence of creating a circular economy or creating a closed loop recycling, system. And if we look at water cycle, we know water is a finite source now because we learn it. But, nature has been carrying out that water cycle process so well for billions of years, and it has created this illusion of infinity. Even today, when it rains, we feel we've got new water. But it's not new water. The reality is that there is no more water on Earth today than there was 4 billion years ago. So fundamentally, nature has been recycling it for billions of years. What we're drinking today was essentially dinosaur pee at one point in time. Right? What we need to do is to replicate nature. We need to recycle our water over and over again. And that is what we want to do. We want to create that awareness that nature doesn't have waste. We humans call it waste. And what happens when you call something waste? You just have this attitude, I want to get rid of it, I want to make it invisible. But the minute you start considering it as a resource, you start seeing the value in it.
True.
So that's what we want to do. We want to create that awareness so that everybody is able to recycle their wastewater, because that is the only way we can have a water secure future. And anybody who wants to, whether it's a small house or if it's a small community, or if it's a school, if it's a college, even if people want to, implement it in their public parks, we've done that in Gurgaon. It's very doable. Parks are parching away in summers, and whatever little water that they get is again fresh water, again insanity, using drinking water to water these parks. So there are a huge lot of areas that, the wastewater recycling can be implemented. And we're looking to just create that awareness that wastewater can be recycled, and it can be done in a cost-effective and a sustainable way. So I think that is where most of our efforts go into.
That's wonderful. I mean, creating awareness as a first step, just like how this podcast aims to create awareness about all the things around getting to net zero carbon emissions and all sustainability stories. That's the intent, create awareness, and I'm sure it'll just snowball. I mean, it'll just snowball as time progresses and a lot of stories, positive stories come out in the open. I think it'll just a matter of time. Well, Aditi, it's been wonderful catching up with you on this particular topic. It's very interesting, and we don't really give it enough thought to kind of think about what happens after we flush the water. So what happens to it? So we don't take time to think about that because we have access to resources and we kind of exploit it without thinking about the future. So it's been wonderful having you on the podcast. Thanks for taking time to join me on the show today.
Thank you so much, Girish, for the wonderful interaction.
Yes, we concluded the conversation reminding ourselves that nature works on closed loop systems with feedback both positive and negative. Interestingly, in the recent past, a scientific journal concluded that even rainwater, which for long has been considered the purest form of water, is not anymore so. That's really unfortunate on where we are headed. But we can definitely undertake small actions at our end and make it count in ensuring the closed loop recycling of water. So the action item for this episode, well, please see if your household or apartment complex has water recycling units. Well, even before that, go around your residence and check if all the taps, pipes and fittings are working fine. In fact, I did that exercise recently and figured out one small leak, a very very small one, which I fixed instantly with tools in hand. So yes, water is precious and piped water is even more precious because it takes a lot of energy to treat it, pump it and deliver it to your taps, which is also a huge contributor to the emissions. So I will leave you with that thought. For more interesting sustainability stories, you can also follow terrageneration.com, our friends who are creating the beautiful artworks that you see in the recent episodes. They are a content agency specialized in telling the stories of people and organizations working in climate, biodiversity conservation, and sustainability. The links to connect with Aditi will be in the show notes section of this episode, so please do check and reach out to Aditi to know more about wastewater treatment. And remember, please spread the message about Mission Shunya podcast in your network. It just takes about 30 seconds or less. And if you haven't left a review or rating on Apple Podcasts, please do so. Until next time, this is Girish Shivakumar signing off. And as always, thank you for listening.